All right, welcome. It seems like every organization out there is sitting on a literal mountain of data. But here's the billion-dollar question. What does it all actually mean? So today, we're going to dig into the foundational techniques that help us turn all that raw data into real, actual understanding. So picture this. You've got data on 2 million customers. I mean, that's awesome, right? That's a huge asset. But it's also a massive headache. How do you even begin to analyze them? Who are they? What do they like to buy? Trying to answer those questions one by one? Forget it. It's just not going to happen. And that right there is the core challenge for pretty much everyone today. It's about making that leap from just having a ton of data to actually understanding what it's trying to tell you. We've got to find the hidden patterns buried in there. Otherwise, let's be honest, we're just flying blind.
Okay, so how in the world do we start to tackle this data mountain? Well, the very first step, and honestly the most crucial one, is something called descriptive analytics. It really is the foundation for everything else that comes after. Now here's a really key point. Descriptive analytics is not about predicting the future. It's not a crystal ball. Its main job, its whole purpose, is to give us a clean, clear, structured summary of what's already happened. It just describes the data so we can finally start to make sense of it.
So, what kind of tools are we talking about here? What's in the toolbox? Well, the three main techniques are clustering for grouping things together, association rules for finding relationships, and outlier detection for spotting the oddballs. And to really get a grip on this, we're going to zoom in on the most fundamental one of them all, clustering.
Right, so back to our 2 million customers. How do we take all those individual data points and magically turn them into, say, 4 or 5 meaningful groups? The answer? It's all about a super powerful technique called clustering.
At its core, the idea of clustering is actually pretty simple. It's all about finding data points that are alike and grouping them together. Think about it from a marketing perspective, right? Instead of trying to talk to 2 million different people, you can suddenly see these distinct segments like high-spending city dwellers or budget-focused families. Much easier.
So this is where we start. Imagine all our customer data just thrown onto a chart. It's a mess. A sea of dots with no rhyme or reason. It's basically just chaos. You can't see any patterns, any structure at all.
So how does an algorithm, a piece of code, actually bring order to all this chaos? It's pretty cool, actually. It follows this step-by-step repeating process. First, it just throws all the data points onto the graph. Then, it makes a few random guesses for where the centers of the groups might be. Next, for every single data point, it asks, which center are you closest to, and assigns it to that group. And here's where the magic happens. It looks at all the new groups it just made and calculates the new center for each one. Then it just repeats that whole process over and over again until the groups stop changing. Pretty smart, huh?
And the result? It's a complete transformation. That mess of dots we started with is now neatly organized into these distinct, meaningful segments. We now have clear customer groups, each with its own shared traits. Just like that, we've gone from chaos to clarity.
Okay, that's incredible. But it probably brings up a pretty big question in your mind. I mean, how does a computer, which only understands numbers, figure out something as human-sounding as likeness or closeness?
Let's pop the hood and see what's actually going on in the engine.
Well, the answer, surprisingly, often comes down to something you probably learned back in math class: Euclidean distance. It's literally just the straight-line distance between any 2 points, as the crow flies. And in the world of data, that simple distance becomes a super powerful way to measure similarity. The closer 2 points are, the more like the algorithm assumes they are.
It's such a simple idea, but it's really powerful. The whole algorithm is basically built on this one rule. Points that are closer together are more related than points that are farther apart. That's it.
Okay, so what about the weirdos? The data points that don't seem to fit into any of the groups. The odd ones out. Well, it turns out they're just as important, and they've got a special name. They're called outliers. The difference here is really simple, but it's super important. A cluster, right, is a bunch of similar points that all hang out together and form a pattern. An outlier, though, is that one lonely data point way out in the middle of nowhere. It's the exception to the rule.
So why should we care about these lonely outliers? What's the big deal? Because finding them is a whole field in itself called anomaly detection. I mean, think about it. What is a fraudulent credit card purchase? It's an anomaly. What's a critical error in a server log? It's an anomaly. Clustering is what helps us find these needles in the haystack.
All right, we've covered a ton of ground here, from the chaos of raw data to these nice, neat clusters and even the outliers in between.
So let's bring it all home. What's the bottom line? Why does any of this actually matter in the real world?
At the end of the day, it's all about one thing: turning data into action. You're taking this overwhelming amount of data and boiling it down into manageable chunks. And when you do that, you start to see patterns you never, ever would have noticed otherwise. And that lets you do things like launch way smarter marketing campaigns or spot a huge problem like fraud before it gets out of hand. Really, it's the absolute foundation for any kind of more advanced analytics you might want to do later on.
So I'll just leave you with this one question to chew on. No matter what kind of data you're working with, customers, sales, server logs, whatever, what powerful hidden patterns are just sitting there, waiting for you to find them? Hey, if you found this breakdown useful, do us a favor and hit that like button. Share it with someone, and definitely subscribe for more explainers just like this one. Thanks so much for tuning in.